Welcome students. This is tips to DLD for end examination. So I request you to study all the topics in the syllabus. Okay. Here I am going to give some hints to prepare the end examination. Consider the first unit. In the first unit, in the digital system, binary numbers and number-based conversions. These are the topics. So the one more question will be asked from the number-based conversions. Okay. So one number to another number conversion. For example, binary to octal, binary to decimal, binary to hexadecimal, like that. Okay. Likewise, different conversion is available. So they will ask this type of conversion. Okay, in single mark question. Then binary codes. Okay, then binary storage registers, this may be also in one mark question. The next one is a binary logic. So binary logic is on the basic logics used in that way. That is also maybe one more question. Then basic definitions. Okay, and Boolean algebra. The definitions of Boolean algebra is very important, so you have to study all the definitions. Okay, right? What are the definitions? Are there all the theorems? Okay, right? So before that, in a number system, you have to study what is Cray code, then what is ASCII code. Okay, then these are important one. Then in binary logic, you have to study the Boolean algebra, the basic definitions. Okay, the associative law, commutative law. Okay, then distributive law. Okay, then some equations. Okay, right? These are very important. So by using this equation, you can solve the problems. Okay, in the first unit. And distributive law, etc. Then postulates and theorems. Okay, so these are the all the postulates are present here. Okay, all the postulates and all the theorems are present here. By using this, you can reduce the equation. Okay, so these type of problems are asked from the first unit. Okay, so they will give one equation, then you have to reduce the equations by using the theorems and postulates. Then Boolean functions. So they will give a one equation, one function f equal to x plus y dash z. It's an example function. By using this function, you have to implement the logical circuit diagram. Okay, so you have to implement the logical circuit. See, as a second example, they give a one function, then from the function you have to implement the logic circuit, then reduce the function. Okay, then after that, and they will give a function. It is in a large terms are available, so you have to reduce the terms, and after that you have to implement the logical circuit. Okay, right? These are the problems in a unit 1. Then this is a also minimize the Boolean expression. Okay, then finding the complement of the given function. How to take a complement of the given function? They will give f, then we have to find the f dash. Okay, so by using the postulate and theorems, you have to complement the given function. The next one is the canonical and standard form. In that, so many forms are there. Actually, sum of product and product of sum, the min term and the max term. So by using this, you have to reduce the equation. So consider one equation, f equal to a plus b dash c. Express the equation in sum of min term. So from the equation 2, you have to find the min terms, the numbers. Min terms means numbers. So 1, 4, 5, 6, 7. These are the min terms. So they give a f equal to a plus b dash c. So from that you have to find these numbers. Okay, that is a min terms. Similarly, you can find the max term also. Okay, so this way they will ask the problem. This is a max term. The pi represent max term, the sum represent min term. Okay, then conversion between canonical form. Okay, one min term to max term to min term. Okay, this type of conversion. So these are the problems will be asked in unit 1. Okay, The next we are going to see the unit 2. In unit 2, so it's a logic gates and gate level minimization. Okay, in unit 2 we have the map method. Okay, k map 4 variable, 3 variable, 5 variable. Then sum of product simplification, product of sum simplification, don't care condition. Okay, then NAND NOR implementation. Okay, these are the topics in unit 2. So what are the problems will be in unit 2? First one, the logic gates. So in one more question they will ask the truth table of the logic gates and the symbol of the logic gates. Okay. Then trigger. Okay, positive edge trigger. What is negative edge trigger? Then level of integration. Small scale integration, medium scale integration, large scale integration, then very large scale integration. Okay, so these are the one more question. This may be a one more question. Then what are the different logic families are there? That is the digital logic families: TTL logic, ECL, MOS, CMOS. Okay, what are that? Then another important one more question was what is fan out, what is fan in, then what is power dissipation, then what is propagation delay. These are the important one more question. Then noise margin also. Okay, what is noise margin? Okay, these are the important one more question from unit 2. Then after that, map method. In map method you have a k map. Okay, so 3 variable k map and 4 variable k map is very important. Okay, so initially they will give a one min term, then from the min term you have to convert the min term into equation, that is a reduced equation or simplified equation by using k map. Then this is also they have a one min term, then by using the k map you have to find the reduced equation. Then problem 4c. Here it is a 4 variable but each term having 2 variables. So you have to convert the 2 variable into 4 variable by multiplying y plus y dash or x plus x dash or z plus z dash. Okay, then after that you have to find the min terms. Then after finding the min term you have to use the k map to find the reduced equation. The next one is a 4 variable k map. In 4 variable k map the same process. Okay, simplify the boolean function. So they give a large equation. So this equation having 4 variable but sometimes having 3 variables. Okay, so you have to convert the 3 variable into 4 variable by multiplying d plus d dash and a plus a dash or b plus b dash, etc. It depends upon the requirement. Then after that you have to convert the particular term into number, binary number. Then by using the binary number you can find the min term. So f of a b c d equal to summation of 0 1 2 6 8 9 10. These are the min terms. By using this min term you can form the k map, then you can find the equation. Then prime implicants. Okay, so all the grouping is called as a prime implicants. It's a essential prime implicant. It's a single group. Okay, so most important that's the essential prime implicant is a single group. Okay, it is independent of other groups. Then next one is a 5 variable. 5 variable is also same as that of 4 variable. Okay, but we have to develop 2 k map and we have to combine both the k map outputs. We have to also study the 5 variable. The next one is a product of some simplification. So they will give a min terms a b c d equal to sum of some numbers. Okay, then you have to find the product of sum and sum of product by using k map. What is product of sum? If the summation, okay, function having summation means that is a sum of product. Okay, if the function having pi, then it is a product of sum. If it is product of sum, you have to put zeros in k map. If it is sum of product, you have to put 1 in the k map and group. Here two things are in single k map. The zeros represent sum of product, sorry, product of sum. Okay, the zeros represent product of sum, the ones are represent sum of product. Okay, both are different. Don't confuse, most of the students confused in this. The next one is a came up with don't care condition. Okay, so in don't care condition you have to group the min terms along with the don't care. Don't no need to group don't care only. Okay, you have to group don't care and min terms or max term. So consider the problem. So min terms are there and don't care numbers are there, both are combined, then we grouped. Okay, this is a came up with don't care. Then after that NAND and NOR implementation. So how to use NAND and NOR gates to develop other gates. In your lab you have studied NOR gate by using NAND gate. Okay, XOR gate by using NAND gate. Okay, so these are the NAND and NOR implementation. Okay, by using this implementation they will access problem. They will give one min terms function f equal to summation of 1 2 3 4 5 7. Then from that you have to develop the KMF. Then by using the KMF you have to implement the NAND gates. Okay, so implement the function by using NAND gate or NOR gate. Okay, right. So this is a very important. Okay, so in last time they asked this type of question. They gave a one function, then by using a KMF you have to reduce the function. Okay, the min term into function. After that you implement the logic circuit by using NAND gates only. That is an important thing. Similarly NOR implementation is also there. Okay, this is also NAND implementation, the NOR implementation also there. Okay, so in the second unit these are some importance. The non-degenerate forms. Okay, right. So consider the four type of gates and or NAND NOR. We assign one type first level in first level and other type in second level, so that we can form 2 power 4 equal to 16 different combinations. Okay, in that 8 are said to be non-degenerate and another one 8 are degenerative. Okay, so you have to, this question may be asked in a 1 mark. And or invert implementation. So they will give one min terms or equations. From the min term you have to convert the min term into equation by using KMF. Then after that you have to implement the circuit by using and or invert. AND gate, then OR gate, after that NOT gate. Okay, this is a and or invert implementation. Okay, exclusive OR by using this method. Okay, then parity generation. Okay, parity generator. So it is important. So parity is a error checking, and in error checking we are using parity. So how to generate the even parity and odd parity. Okay, you have to study this one also. Okay, then Hamming code in a second unit. Okay, Hamming code is an important problem. Okay, already discussed in the class. Okay, then after that unit 3. In unit 3 we have different topics, that is a combinational logic. In a combinational logic circuit we have a analysis procedure and a design procedure. Okay, right. Then binary adder, subtractor, decimal adder, binary multiplier, magnitude comparator, decoder, encoder, multiplexer, then VHDL code. Okay, these are the different topics in unit 3. So in unit 3 is a combinational circuit. In combinational, actually in unit 3 what is the difference between combinational circuit and sequential circuit? That's one of the important question. Then list the analysis procedure. Okay, these are the some 6 steps used in analysis of combinational logic. So in analysis they will give one logical circuit. From the logical circuit you have to find the you have to find the smallest equations. Okay, from the circuit you have to find the simplified equation. This is the analysis of combinational circuit. Answer the second problem. Say circuit, from the circuit you have to find the smallest equation. The next one is a design procedure. In design procedure the procedure may be asked in the 2 mark questions, 1 mark question. Okay, then sometimes they will ask in 2 mark also. Then this is one example of the design a logic circuit for BCD to XS3 code converter. Okay, this is one of the important question. So BCD to XS3 code converter. So this side BCD code, this side XS3 code. Okay, then you have to form a KMF for WXYZ, and you have a 3 equations for WXYZ. Then by using that equation you have to form the circuit. So this is a design. Generally design means you have to implement the circuit in any unit. If they ask design means you have to develop the logical circuit. The final output is a logical circuit in design. Okay, then this is a second example. So design a combinational circuit with 3 input and 1 output. The output is 1 when the binary values of input is less than 3. This is one condition. The binary value is less than 3 means output 1, otherwise the output is 0. This is a condition. Based on the condition you have to make a truth table. Okay, x, y, z the 3 variable, so 0 to 7 is a truth table. So the binary output is 1 for 3 and less, and 0 for more, and from that you have to draw the KMF. By using the KMF you have to draw the logic circuit diagram. This is a design. Okay, this is a combinational circuit design. Then after that, binary half adder, half adder, full adder, these things are you have already studied in lab. Okay, then 4-bit adder. Okay, 4-bit adder is done by 4 full adder. Okay, in mid to this question is asked, somebody is missed. Okay, right? So 4 you have to use 4-bit adder. N-bit adder means you have to use full adder. Okay, right? So 2-bit adder means that is a half adder. 3-bit adder means that is a full adder. Okay, 4-bit adder means you have to use 4 different full adder. 5 bits means you have to use 5 different full adder. N bit means you have to use n different full adder. Okay, so this is a adder. Similar way, the subtractor also, half subtractor, full subtractor. So the logic diagram and implementation is very important. Then it's a binary subtractor. It's a 4-bit binary subtractor. So as like a 4-bit full adder, it's a binary subtractor. Small change in the circuit. They are using XOR gates in a input and output. Then decimal adder and BCD adder. This is a BCD adder circuit diagram. Actually BCD adder is by 4 full adder. Okay, and 4-bit binary adder. So this circuit is very important. If you know this circuit, you can explain the operation by using that circuit. Okay, read the text, then you will understand. Then binary multiplier, it is based on ordinary multiplication process. Okay, so it is a 2-bit AB, it is a 3-bit. Okay, 4 cross 3 binary multiplier. Okay, so just note down the circuit diagram. And next one is a magnitude comparator. Magnitude comparator is very important. Okay, it is a 4-bit magnitude comparator, and sometimes they will ask the single bit magnitude comparator. Single bit means you have to use the first set A3, B3 and X3. This is a single bit magnitude comparator. Okay, so this diagram is a single bit magnitude comparator. So you have to explain this diagram and its operation. Then decoder. So you know already studied in a decoder in your lab. Okay, so it's a decoder encoder already you have studied. So you have to use the same circuit diagram in your observation. Okay, so and same truth table. This is a truth table of encoder. So encoder means n bit and 2 power n output, n bit input and 2 power n output. Decoder means 2 power n input and n bit output, just opposite. This is an important question. Implementation of full adder with decoder. Okay, implementation of full adder with decoder. How to implement full adder with decoder? It's a very important question. So in full adder we have 3 inputs x, y, z. Okay, 2 outputs sum and carry. So based on that you have to form the truth table. Then this is a circuit diagram. Then find what is sum and what is carry. Sum equal to 1, 2, 4, 7. Sum equal to 1 for 1, 2, 4, 7 and carry equal to 1 for 3, 5, 6, 7. So very simple. It is a 3 to 8 decoder. Then you have to connect all the sum. Okay, sum equal to 1, 2, 4, 7. So you have to connect the line 1, 4, 2 and 7 to some OR gate. Similarly 3, 5, 6, 7 to carry OR gate. Okay, it is a implementation of full adder with decoder, very important question. Next one is the encoder. So you have to know the truth table. So 2 power n input and n output. Then parity encoder, even parity and odd parity. Okay. So this is one implementation, 4-bit parity encoder by using that K-map. Okay. So D1, D2, D3 is a inputs. Actually, this is a original truth table. This is a extended truth table by using this truth table. Okay. Then XY is a output. V is the enabled. Okay. Then multiplexer is very important. Already you have studied in multiplexer in your lab observation, so you have to use the same circuit diagram and the truth table. Okay, but they are not asking the multiplexer theory, they are asking the problem, the Boolean function implementation in multiplexer. Okay, so this is a Boolean function implementation in multiplexer. In last end examination they have asked this question. This question is present in a old end examination question paper. So this is a Boolean expression implementation in multiplexer. Okay, right, very simple. So they have three xy z 3 variable Boolean Boolean function here. Then by using that you have to implement the multiplexer. Okay, and this is one problem. Then this is a second problem. This is for 3 variable a b c d, sorry, 4 variable. This is a 3 variable x y z. Okay, very important. Just read the text and you will understand easily. Then 3 state gate or tri-state gate is a important 1 mark question. So set, reset and high impedance state. This is a 3 state gate. Okay, multiplexer with a 3 state gate. In 3 state gate we can make a short circuit in a output. Okay, we can make a short circuit, but in multiplexer in other gates we cannot do. So the 3 state logic is very much used in the logical circuit. Next one is the VHDL program. Okay, so VHDL program PDF is available in separately. Okay, the VHDL program for the half adder, full adder. Okay, it is available here. Okay, HDL and VHDL nodes. So refer this. Okay, difference between HDL and Verilog, VHDL and Verilog. Then all the programs are available here. Okay. So next we are going to see unit 4. In unit 4 is a very smaller unit. Okay, synchronous sequential logic. So sequential circuit, latches, flip-flop, then analysis of clocked sequential circuit. Okay, and a design of synchronous clocked sequential circuit and state detection, state assignment. These are the topics available in the unit 4. So I will open a unit 4 and notes. So this is a unit 4. So here what is synchronous, what is asynchronous, the difference is very important, which is will be in a 1 mark question. Okay, this is some theory about synchronous circuits, then asynchronous sequential circuit, then latches. So you have to study all the latches, SR latch, D latch, circuit diagram, truth table and operations. Okay, very important. Then another one is a S dash or dash latch. Okay, by using NAND and NOR. Okay, this is also. Then D latch, what is D latch, how do you convert the D latch from other latch? Okay, then truth table. Then what is transparent latch? Okay, it is a one of the important 1 mark question. What is transparent latch? Okay, so read the text here. The next we are going to see the flip-flop. So the flip-flop is taken from latch. Okay, here one important 1 mark question, that is what is the difference between flip-flop and latches. Then another one important 1 mark question is what are the triggers? What is edge trigger? What is level trigger? Okay. Then D flip-flop. within T latch. Then so you have to study all the flip-flop. What is SR flip-flop? What is JK flip-flop? What is D flip-flop? What is T flip-flop? Okay, and its truth table, then operation, characteristic table, all are important. Okay, so toggle flip-flop, T flip-flop, and a symbol, a logical symbol, then circuit diagram, truth table, then operation, then characteristic table and characteristic equation also. Okay, these are some characteristic table of the flip-flops. And a characteristic equation is below the table here. Then SR flip-flop. Okay, so truth table, characteristic table, then KMF, then characteristic equation. These are the important. This is a JK flip-flop, logical circuit diagram, then truth table, then characteristic table. From the characteristic table you can form the KMF, then from the KMF you will get a characteristic equation. Then this is a T flip-flop, then logical circuit diagram, then truth table, characteristic table, then characteristic equation. Okay, next one is analysis. In analysis of sequential circuit, they will give a logical circuit diagram. Okay, from the logical circuit diagram you have to find the equations. Okay, so just you have to point the variable, okay, from output to input, then you can write the equation for the particular variable. Okay, right, then combine all the variable, then state table, then from that you have to form the state table. So the state table consists of present state, input, next state, output. Then from that you have to draw the state diagram. Okay, in analysis means circuit to state diagram. You have to convert the given circuit into state diagram. This is a second example. They give one circuit, then from the circuit you have to write the equations. From the equation you have to form the state table. From the state table you have to form the state diagram. So this is a analysis of circuit. The next one is a state reduction and state assignment. Very important, large question, big question. Okay, it's a 3-mark question. So state reduction and state assignment, they will give a large state diagram. Then from that you have to reduce the state by using state table first, then reduce the state table again, if there is any possibility reduce the state table again, then finally you have to draw the reduced state diagram. Then state assignment means you have to assign the binary number to the state A, B, C, D, like that. Okay, that's the state assignment. Next one is the design of clock sequential circuit. So the design procedure is a 9 step is there, so it is very important. So the design procedure may be asked in a 1-mark question. Okay, what is the design? First they will give a state diagram, then from the state diagram you have to write the state table, then state table reduction, then state table assignment. Then from the state assignment table you have to find the how many flip-flops we need. Then by using the how many flip-flops count, and you have to choose which flip-flop you are going to use in your circuit, T flip-flop, D flip-flop, JK or SR. Okay, choose anyone. Then after that, based on the flip-flop you can to form the excitation table. Excitation table consists of present state, next state, then flip-flop input and output. Then you have to form the KMF for flip-flop inputs, okay, right, and output also. Then you will get a equations. From the equation you have to draw the logical circuit diagram. Okay, so these are the unit 3. Unit 3 is very simple. Okay, then next we are going to move to unit 4. Sorry, now we have studied the unit 4. Next unit 5. Unit 5 is a asynchronous sequential logic. Okay, so it's also same as of unit 4. Okay, it has an analysis procedure, it has a design procedure. Okay, right, and it has a VHDL code for flip-flop and a decade counter. Okay, let me see the notes. So unit 5. So asynchronous sequential logic. So what is the difference between synchronous sequential and asynchronous sequential? Then this block diagram. Last end examination they asked this block diagram. Okay, short notes on asynchronous sequential logic and its operation. So it has a combinational circuit along with the delay elements, then n input and m outputs. Okay, so you have to explain this block diagram. Then analysis procedure, here analysis procedure, you have a circuit as a in question. Okay, then from the circuit you have to draw the state table by using some equations. So from the circuit you can form the equations. See, this is a circuit. Here the equation is formed. From the circuit you have to form the equation. Then from the equation you have to form the state table. Then from the state table you can draw the transition table. Okay, transition table is taken from the state table. Then you go to circle the stable state. The present state and the next state both are same, then that is called stable state. Then circle the stable state. Finally you have to draw the output map. The output map only for the stable state, okay, not for all state. So you have to give output for stable state and give dash for unstable state. Then this is the second example problem. In second problem they have equations. Okay, they have a equation. By using the equation you can draw the logical circuit diagram. Then from the equation you can draw the state table, then transition table, then output map. Okay, so this is the analysis. Okay, then this is the third example. They will give one equations. Okay, right. Then from the equation you have to draw the circuit diagram. Then the circuit diagram converted into state table, then state table converted into transition table, then transition table converted into output map. This is the analysis. Then next one is the circuit with latches. Okay, so some circuit with latches. So this also same procedure. From the circuit diagram you have to draw, find the equation. From the by using the equation form the state table, then transition table, then output map. If possible output map, otherwise leave it. Then SRLH by using NAND gate. Okay, right. Then what is race around condition? It's an important one mark question. What is race around condition? So important one mark question, so you have to study. If the JK flip flop both inputs are 1 1 means it will change the output state from 1 to 0, 0 to 1 in continuous manner. To avoid that you have to use a master slave flip flop. Otherwise you have to use higher clock than the del t. Okay, see the notes, and separate PDF is there for race around condition. Okay, then the design of asynchronous sequencer circuit is very complicated question. Actually the solution is very complicated. There's so many steps are there. So they will give some paragraph. Okay, in that they will mention some condition. Okay, by using that you go to form the flow diagram. This is a flow diagram. Okay, in flow diagram we have a x, y, z. Okay, x, y are input, z is the output. This is a condition. So likewise you go to draw the flow diagram. Then from the flow diagram you go to form the state diagram. From the state diagram you go to form the primitive flow table. From the primitive flow table you go to reduce the primitive flow table again. Then after the reduction you go to assign, okay, right, some values. Okay, right. Then you have to make a K-map by using that primitive flow table. Then from the K-map you will get the equation. Then from the equation you can implement the logical circuit. This is the design. So design means you have to draw the logical circuit at the end, that is the final. So don't forget, design means logical circuit you have to draw. Then next one is the all are theory questions. The registers, what is registers? Then serial in, serial out, parallel in, parallel out, 4 types of registers. So you have to draw the logical circuit and you explain the operations, and you have to draw the clock. Okay, the timing diagram also. This is a very easiest question. Then counters, next counters. So around 6 counters are there. Okay, already I published one video recording counters. So if you have time please watch it. So in counter you have to draw the logical circuit diagram, then operation, then truth table, then after that timing diagram. These are the important. Ring counter, okay, ring counter, circuit diagram, explanation, truth table. Then here from the truth table you can draw the timing diagram. It's a Johnson ring counter. So truth table, operations. Then synchronous counter, it's a 4-bit synchronous up counter. Okay, up counter. Then you can draw the truth table or logical diagram, timing diagram. Then this is a 4-bit down counter. Okay, circuit diagram, operation, and the timing diagram. Okay, then in the counter, another one important counter is the bidirectional counter and universal counter. Okay, universal counter is very important question. Then BCD or decade or mode 10 counter. Okay, so if you know this question, if you can understand this one, you can design any counter. This is a mod 10 counter. So mod 10 means this counter can count 10 different values from 0 to 9. When it is reaches 9, it is counted to 0. If it is mod 5 counter, it will count 5 values 0 to 4. When it is reach 4, it will again automatically reach to 0. When it is mod 12 counter, it will count 12 different values. Okay, right? So when it is reach 11, automatically converted into 0. Okay, so same way this is a mod 10 counter. The design is, so first you have to know the excitation table for flip-flop input. That is very important. Here excitation table for all the flip-flops are there. Okay, JK, T flip-flop, D flip-flop, SR flip-flop. Okay, so the next one, the table is present state, next state, then T flip-flop inputs. Okay, so by using this excitation table, you can assign any flip-flop to your design. Here I assigned T flip-flop. Okay, so total number of flip-flops are 4. What is the condition? So 2 power n greater than equal to n, capital N. Okay, 2 power n is the number of flip-flop, n is the number of flip-flop, capital N is the value of mod. Okay, okay. Then flip-flop inputs are converted into truth table, converted into KMF. Then by using the KMF, you can implement the logical circuit. So this is a design. Consider any design, it is an implementation of logical circuit. The next one is a sequential programmable device. These are unit 6. Okay, it is available along with the unit 5. Okay, here so 3 types: SPLD, CPLD, FET, all are theory questions. Okay, right, you can easily write. So these are the field programmable gate array. Okay, these are the theory question, just read this. The next way I am going to see unit 5, unit 6. Unit 6 is a fully theory, very easiest unit. Okay, so study all the topics: RAM, ROM, then PLA, then PAL. Okay, then VHDL code for decade counters. Okay, right. So let me see the unit 6 notes. So in unit 6 as a programmable logic, right? Okay, right. So the random access memory, RAM. What is RAM? What is memory cell? How the read operation takes place in RAM? They have to ask how to perform read operation, how to perform write operation. So you have to draw the timing diagram. Memory read operation, memory write operation, very important. The next one is a read only memory, ROM. Okay, so in ROM they will ask the problem. Okay, in ROM, that is, don't confuse the ROM with PAL and PLA. Okay, most of the students have a confusion with ROM and PAL and PLA. Okay, so this is a problem. So they will give one equations. Okay, right, by using that equation you can implement the program the ROM. Okay, so the ROM program is very important. Okay, so it is one of the problem. Actually I published on videos particularly for this ROM and PAL and PLA problems. Okay, then and error detection and error correction. Error detection is done by parity, error correction is done by Hamming code. Here Hamming code is explained well, so please follow this method. Okay, please follow this method. Okay, it's a very important question. Hamming code also available in unit 1. Okay, then PLA, this is a programmable logic array, so it's a very important problem in unit 6 and theory also. Okay, so then the difference between PAL, PLA and PROM is a very important question. So here consider two function f1 and f2. So here we have to implement the function in this program logic array. Program logic array means AND array plus OR array, both are programmable. Okay, the next one is a programmable array logic. Here AND array is programmable, OR is a fixed, so we cannot program the OR. Okay, so this is a programmable array logic. Here also we have a problem. They will give one function, then by using the function you have to convert the equation by using KMF. Then after that you have to implement the equation in the PAL. The next one is a memory decoding. Okay, this is a memory decoder. So how the memory decoding is takes place. Okay, what is binary cell? Okay, these are the button one. Then how the memory is stored, two dimensional decoding. Okay, then address multiplexing, how the address is multiplexed. Okay, right. So these are the important theory question, just read it. Okay, so if you read the importance and some 1 mark and b questions, you will get surely good marks. Okay, right. So study well, all the best. If you have any doubt, please contact me. Okay, right. So please use the link. Okay, tinyurl.com, then slash csc dld notes. Okay, use that link, then you will find all the notes. Okay, right. All the best students, study well. Thank you, all the best.